Graphing radical functions. As always, we're going to start here with the state standards, and then you have the success criteria. To be successful today, you need to be able to graph radical functions, describe transformations of radical functions, and write functions that represent transformations of radical functions. You have one vocabulary word. Make sure this is in your notes. A radical function contains a radical expression with the independent variable in the radicand. When the radical is a square root, the function is called a square root function. When the radical is a cube root, the function is called a cube root function. Remember here where it says independent variable, usually that is your x. So the independent variable are the numbers that you choose, and then you plug those in to find the y value. So you plug your x's in, solve to find y, and y would be your dependent variable. Example 1, graphing radical functions. Graph each function, find the domain and range of each function. All right, so here's a couple examples of parent functions. So you've got the parent function, f of x equals the square root of x. So this is what the parent function of a square root looks like. And then this is the parent function of your cube root function, and it also has the domain and range here. Knowing your parent functions, kind of what that visually looks like, what that type of function looks like, is very important. So remember what those are, and then these would just be transformations of that. All right, so like before, we're going to pick x's and plug it in to solve for f of x, which is our y value. So again, x will be our independent variable, and y will depend on what x's we pick. Since we're multiplying by 1/4, I'm going to choose numbers that are easy to multiply by 1/4. So I'm going to choose multiples of 4. So let's see, we got 0, 4, 8, and 12. All right, if I plug in 0, 0 times anything is 0, so that's going to be 0, 0. 1/4 times 4 is 1, so the square root of 1 is just 1. And then 1/4 of 8, 1/4 times 8 is 2, and the square root of 2 is just the square root of 2. And 1/4 of 12, 1/4 of 12 is 3, so that's going to be the square root of 3. So we may need to find some decimal values in order to graph these, but let's choose one more multiple of 4. So let's choose 16. So 1/4 of 16, 1/4 of 16 is 4, and the square root of 4 is 2. So you can see that these numbers here are going to fall between 1 and 2. So we'll go ahead and graph the ones that are easy to graph. So let's graph 0, 0. All right, since we only have a scale of 10 here and these go up to 16, let's go ahead and change our scale. So let's say this is 4, 8, 12, and 16. And up the side, let's say this is 1, 2, 3, 4. All right, so if we want to graph 4, 1, here is 4. Let's go up to 1, graph another point there. And then the next one's going to be 16, 2, which is the next easy one to graph. We can graph that point here. And really you could sketch this curve with just 3 points. And you know that these two are going to fall somewhere between the second 2 points there. But let's look and see what the square root of 2 is. So we can kind of sketch that a little bit to scale. So let's say we have square root of 2. Is going to be 1.41. And the square root of 3 is 1.73. So 1.41, 1.73. So 1.41 and at 12 would be 1.73. So again, it's going to be points that fall along that curve. So that is kind of what that would look like if you sketch that curve. So the domain would be all x's greater than or equal to 0. And your range would also be greater than or equal to 0, but your range comes from your y values, your vertical axis, so y greater than or equal to 0. G of x equals -3 cube root of x. So remember, this is your parent cube root function over here. So the negative is going to make it a reflection across the x-axis. So that means this part's going to be up here. So it's going to be more like this. And then the 3 is going to be a vertical stretch by a factor of 3. So transformations work very much the same with different types of function. To save a little time, let's use our calculator to graph this one. Because most of the time they're not going to ask you to graph this by hand on a standardized test like the EOC or the ACT. So let's use our calculator. We're going to type in -3 and then go to math to find your cube root button, and then cube root of x. All right, once you have that typed in, you're going to hit graph. And again, like I said, it's going to be the reflection here because of that negative. And it's a vertical stretch by a factor of 3. But you can see it still has that same general shape, even though it's been reflected. If you wanted to make a table of values and graph this by hand, you could go to your table of values, pick out a few points, make a table, and then sketch those points here on your table. I'm just going to use the graph that's provided here. So let me get that and we'll move on. All right, so this is the graph of that function. It also says find the domain and range. So the domain and range. If you look, this is your x-axis and it goes continuously to the left and to the right. So that means it's going to be all real numbers. You also could write that as -infinity to infinity. And the range, even though it goes up not as quickly, it is continuous to go up and it is continuing to go down in both directions. So again, your range is also going to be all reals, which is also written as -infinity to infinity. So you may see it like this on your state test, or it may say all real numbers. Both mean the same thing. All right, study tip, a power function has the form y equals ab to the x power, where a is a real number and b is a rational number. Remember, a rational number can be written as a over b, so it can be a fraction. Could be a whole number as well, but it can be a fraction. Notice that the parent square root function is a power function, where a is 1 and b is 1/2. Remember, the square root can be rewritten as x to the 1/2 power. Example 2, transforming radical functions. Describe the transformation of f represented by g, then graph each function. All right, A part says f of x equals the square root of x. Remember, that's your parent function. That's your parent square root function. G of x equals the square root of x minus 3 plus 4. So remember, the number underneath the radical, that is your horizontal translation. That's your h value. And then this number is your k value. That's your vertical translation. So if you look over here, this is very similar to what we've had before. horizontal is your H, and your vertical translation is K. So we can determine that g of x is going to translate 3 units to the right and 4 units up. So 3 units right and 4 units up. And that would be the difference between g of x and f of x. Then it says to graph each function. So again, let's type these in our calculator and look at what that will look like. So our parent function is just the square root of x. And then we have the square root of x minus 3. Arrow over to get out from under the square root, and then plus 4 to get your vertical translation, and then hit graph. That is your parent function in blue, and that is g of x, the transformation, which is moved 3 units right and 4 units up. All right, so here's the graph. Hopefully it helps you understand what these transformations are when you can visually see that as well. B part says f of x equals the cube root of x, and g of x equals the cube root of negative 8x. So g of x again is the transformation of f of x. And if we look over here, you can see that this negative and the 8 are both under the radical sign. So when the negative is under the radical sign, it's still a reflection, but this time it's going to be a reflection across the y-axis. So it's going to reflect the y-axis. And then the 8, you can see here, this is what always confuses people. All right, so the graph stretches away from or shrinks towards by a factor of 1 over a. So that's very important to remember, that 1 over a. So it's going to be 1 over 8. So what's going to happen to that? So it's going to shrink. You're going to have a horizontal shrink by a factor of 1/8. So let's see. All right, so again, let's graph that and see what it looks like on here. So we're going to graph both the parent function and the transformation. So if I go to y equals, this time I need the cube root of x, so I'm going to go to math to find the cube root button. There's cube root of x. And then go down below and we're going to do cube root again. So I need the cube root button again. And this time we're going to have negative 8x. And then we're going to hit graph. Again, the blue line is your parent function, f of x. And then the red line is going to be the transformation. So that is the reflection across the y. And a horizontal shrink by 1/8. Again, if you forget which color is which, if you go back to y equals, right here it has blue, red, black. So if you graph multiple graphs, this does have a color code on your TI-84 that tells you which graph is which. All right, so I have put the graph here. Make sure, we've looked at this many times over the course of the semester, these transformation ideas. Make sure you practice those, you try to understand those, because this is a major standard that we cover over several chapters. So this is something that's very important that you will see on the EOC. All right, if you have any questions, please let me know.